Hi, this is Dave Thomas. I'm going to try recording some of my Advent of Code attempts. So let's start off with the first one, which will be December the 1st. So we have a long story here about the chief historian and setting out our goals of having to collect 50 stars by solving coding challenges. So let's go down to the actual problem statement here. We have two lists. These are samples. This isn't a real list of numbers that were found on scraps of paper throughout the chief historian's office. And we're trying to work out what these mean. And our first challenge is to try and work out how different these two lists are. And what they mean by how different is this paragraph down here. Pair up the numbers and measure how far apart they are. So we pair up the smallest number in the left list with the smallest number in the right list, and then the second smallest left number and the second smallest right number, and so on and so on. So that immediately says to me that we probably want to sort both lists before we do anything else. Then within each pair, figure out how far apart the two numbers are. You'll need to add up all of those distances. Oh, okay, so we're going to go through the two lists, the sorted, which means we'll be picking the smallest one off each and then the second smallest and so on. So we're going to have to merge those two lists so we can process them in parallel. We'll calculate the distance or the difference between each of the entries, and then we'll produce a sum of the result. Excellent. Okay. So let's wander over here to the work directory. I'm going to create a directory for O1 and pop into it. And let's code this one in Ruby. So let's just call it o1.rb. So we know the first thing we're going to be doing is sorting those two lists. So let's actually get those two lists in. Just for now, I'm just going to type them in because there's only a few entries in each. So the first one is 3, 4, 2, 1, 3, 3. And the second one is 4, 3, 5, 3, 9, 3. And I guess an equal sign would help. Okay, so immediately we've got a problem. Oh, I see, we've got missing spaces here. That's what's wrong. Okay, because it's good to check that your lists are actually the same size before you do anything else. So we know we're going to sort them before we do anything else. So just for now, I'm going to be doing really boring stuff. Oh, thank you, ChatGPT. That's good. Okay, so we now have two lists that are sorted. And what we want to do is to iterate over them in parallel and work out the difference between each of the pairs of numbers. Now, there's lots of ways we could do that. We could have some kind of for loop that basically used an index and indexes over both of them. Or we could iterate over the first one and pick out the element from the corresponding list by just shifting it off the front of the array. But whenever I see this thing about processing two lists in parallel, I immediately think, can I zip them together? And indeed, I can. So if I was to go L1.zip L2, and let's actually just output that. So we'll save that away, split our screen, and if we just run that code, you see what's happened here is we've got a list of lists. The first entry is the first element in list 1, followed by the first element in list 2, and the next entry is the second element in both of them, etc., etc. Okay, so that's a useful thing to get. So now what we want to go is to go through those lists and work out the difference between corresponding entries. So we can do that pretty easily by running our list through map. And map is going to receive the v1 and v2, the two values. And so we need to calculate the distance between them. And That's going to be v1 minus v2, but it's actually not quite, because if v1 is less than v2, then that's going to be a negative number, and we won't be able to add that into our list and actually get a reasonable result. So let's actually make that v1 minus v2 dot abs. So that's the absolute value. So now what we have is a list of the differences. And again, if we wanted to, we could actually have a look at that. So save that away, go down here, and now we have the differences, and you can see the difference between 1 and 3 is 2, difference between 2 and 3 is 1, 3 and 3, 0, etc., etc. So that looks kind of reasonable. So now what we have to do is add them up. And to do that, I just have to put dot sum. So let's go have a look over here. In their example, they say that the total distance is 11. So let's see what we say. We say 11. That means that our processing is close to the processing they do, and it gives you the same number. So let's go for the big list. And you know how this works with Advent Encode. They give you like a, what is this, 6 or 7 element list to start with, and then they'll give you like a massive, massive list. So let's go get the puzzle input. Okay, so that is probably 1,000 lines or so of numbers. I am not going to type those in. Instead, what I'm going to do is copy and paste those in as a string and then parse them out into my two lists of numbers. So to do that, I am actually going to first change my existing code so that it will actually handle this format here. So that way I can make sure that my string parsing and stuff is successful. So I'm just going to copy that out of here, come over here, and make this into a string. So let's call it, oh, I don't know, raw input equals okay. It would help if I could spell input. So all we have to do now is to split it into lines and then split each line around the spaces into 2 fields and then convert those fields to numbers. So that's just a relatively straightforward Ruby chain of method calls. So we're going to take raw input and we're going to split that into lines. And then for each of those lines, we are going to take the line and we're going to split it into 2 fields. And then we're going to map those 2 fields one at a time and convert the string to an integer. And we'll do that by just saying ampersand colon 2i, which is the Ruby way of saying run that instance method on the value that you would have passed to the block. And so we're passing in a string with, hey, say 4 in it. And so we're going to call 2i on that string, and that should come back with the number 4. So let's have a look to see if that's actually processing the raw input successfully. Save that away down here. Not so much. Oh, because I'm not actually looking at it. Ah, good. All right, so there we actually have our data broken out into fields. So now I can say that not the best name. So I can say that L1 equals values.map, and this time we'll take the first element of that 2-element array, and L2 is values.map ampersand colon last. So now we're back where we were before. We have two lists of numbers. We're going to sort them and calculate the distance between. So save that away and come down here. We get 11. All right. So now it's time for the big challenge. We're going to go back here and get the full puzzle input. We're going to copy it. So we're going to go back over here to the code. We're going to remove, actually, no, let's add the new data first. So here's that new data. Yep, there's 1,000 lines of it. And then we'll just get rid of the old stuff. So we'll just quickly check that we've actually got something reasonable at the top here. Yep. So if we save that away and we run our code again, we get a big, big number. Well, let's go see if that's right. We'll take that number here, go over to the advent of code, and we will submit our number. Yay! That was correct. Okay, so let's go on to part 2. So our analysis confirmed what everyone feared. The two lists are very different indeed. But our historians believe that actually some of those things are not numbers, but actually handwriting. And if that's the case, then they would expect the same location to occur multiple times in the list. So can we work out how often each number from the left list appears in the right list? So what we're going to do is calculate a similarity score. We're going to take each number in the left list and multiply it by the number of times that that number appears in the right-hand list. And then we're going to add those all up, and that will give us some kind of similarity score. So what we're going to do is go back to our original 3-4 list here. So I'm going to leave this already because there's no point in getting rid of it. Let me just call it full raw input. And we'll scroll down to here, and we'll just create our test data. And again, back over here to the web page, we'll copy out that data, stick it into our string, and then we're going to go and create our L1 and L2 lists. Now, let's go back and see what we have to do. We have to look at the left-hand list, which is L1 in our case, and for each value in that list, we have to see how frequently that particular value occurs in the L2 list. Now, obviously, what we could do is we could pick the first number out of L1 and then iterate over L2 and count how many times we come across that number, and then do it for the next number, etc., etc. If we do that, we're going O(n) squared, which, I mean, okay, it won't take long on this machine, on only 1,000 elements, but it's still kind of suckish. So what else could we do? Well, what we're looking for is the number of times a particular value occurs in L2. So we're basically wanting to create a histogram of L2. And that's actually pretty simple to do if we just use a hash or a map or dictionary or whatever your language of choice calls it. So let's store our histogram in a variable imaginatively called hist. What we're going to do is we're going to take each of the values in L2 and add it to the appropriate bucket in our histogram. And the histogram is just going to be a hash, and the bucket is going to be the entry whose key is that number, and the value will be the number of times we've seen that number. So we're going to reduce L2, and we're going to reduce it. The accumulator we're going to use will be a hash whose default value is 0, because that saves us some hassle. And we're going to write a little block of code. I'm going to write it in a multi-line block. So we're going to receive that hash into the result value, into the result variable, and we're going to receive the next element in the list in the value variable. And what we're going to do is we're going to say result value plus equals 1, and then we're going to return result. So let's see what that gives us. So again, save it away, pop down here. Oh, that was supposed to be exit. Okay, so that's saying that 4 occurs 1 time, 3 occurs 3 times, 5, 1, and 9, 1. If we go back over here, indeed, there are 1, 2, 3 3s, and then 1 of everything else. Okay, so this must be good. So what we have to do now is to go through list 1 and basically just report the histogram value for, in list 2 for that value. So we're going to do L1.map. There's a value. And we're going to replace that with the histogram value of that value. And remember, if the key doesn't occur in the histogram, it will return 0, so that's okay. So now what we've got is a list of the number of occurrences. And again, if we're not too sure, we can actually do a PP on that down here. Okay, and that's not right, because if we look at our list here, we got 310033, and over here they got 940099. And the reason is that we didn't actually, or I didn't actually read the question properly. Look at this. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that number occurs. So we're actually going to, rather than adding 1, we're actually going to add, well, we can do this 2 ways. We can either add the value in here, or probably slightly clearer, we just have to say v times hist there. So if we do that, now we get the 94099, which is what we were looking for. And all we have to do now is sum it. So again, this is on our test data. We get 31, and 31 is the number that they expected us to get. Excellent. So now we're going to run it on the big list. So I'm going to get rid of this raw input, don't need it anymore, and rename this guy to raw input. So this is going to be using this data, which is the input data set, rather than our test data set. I guess we just see what happens. So we get some massive big number here, and we'll feed that in. That's the right answer. Excellent. So we've just completed day 1. So do I have any kind of observations on this? Well, really just the idea of chaining together a sequence of calls, each of which mutates our data in a particular way, turned out to be a really good approach to take. So to divide our input into individual numbers, we split it into a list based on new lines. So there'll be a 1,000 element list or 998 element list or whatever it is. And then each line has 2 numbers as strings. So we split that line on spaces and then map each component to an integer. So all of our code here is done by chaining and by using map to replace one list with another list. And we take that list of lists, and we're going to split it out into 2 separate lists, L1 and L2, just because it's a convenient way to handle it. And we calculate a histogram. Pretty straightforward. We just basically take an empty hash and we go through L2 and we up the count for each value as we encounter it. And then finally, this is the code that actually goes through and calculates the similarity, I guess is what they call it. And that's by taking each element in L1, looking it up in the histogram to get the count of that element in list 2, multiply it by the element itself, and now we have a list of those partial values, and all we have to do is sum them up. And somewhat miraculously for me, it all seemed to work first time. See you for day 2.